Assalamu alaikum. Good morning, dear students. Today we shall talk about the oxidation of nitrogen containing compounds. In different organic compounds, the most important class of organic compounds are the amines. And amines may be classified into primary, secondary, and tertiary amines. Today in this class, we shall talk about the oxidations of amines and hydrazines. Simple hydrazine is not as much important. We will take the different derivatives of hydrazine, such as phenylhydrazine or any substituted phenylhydrazine. So let's talk first about the oxidations of amines. Let's take first the primary amines. Oxidation of primary amines. We will talk about the three oxidizing agents that are commonly used for the oxidation of primary amines. Number one is the hydrogen peroxide. Second one is the peracids. The third one is the benzoquinone type oxidizing agent, and the number four is the potassium permanganate. So these four oxidizing agents are used for the oxidations of the primary amines. Now, what will be the product of the oxidations of the amines, primary amines? So it depends upon the which reagent you are employing. Let's first discuss the oxidation of primary amine with hydrogen peroxide. So when primary amines react with hydrogen peroxide, the product is oximes. So here we have a CH, NOH. So it's amine. And what is the name of this class of organic compound? Oximes. So you'll have to remember that whenever the primary amine, the amine, what are the primary amines? In which the nitrogen is attached directly to only one alkyl or methyl or ethyl group. So in that case, when it is reacted with hydrogen peroxide, then oximes are formed. I'm writing here a particular example for your better understanding. This is propylamine. So propylamine, upon oxidation with hydrogen peroxide, it changes into oxime. So how this transformation occurs, let's discuss its mechanism. So when you will have a good practice on the mechanism, then you can solve the different problems that you may encounter during the exams. Mechanism. let's take a general primary amine and we are going to react it with hydrogen peroxide. We know that the oxygen, the single bond between the two highly electronegative elements is a very weak bond. So what happens that the nitrogen as a nucleophile attacks on this oxygen, this bond moves over here. So what happens, the one hydroxide ion leaves, nitrogen makes the new bond with one OH, so you get positive charge and OH. What happens next? Because the nitrogen bearing positive charge is seems to be unstable, then deprotonation occurs. So when deprotonation occurs, it changes into this. OH. What happens? The deprotonation occurs, one of the hydrogen is abstracted and the bond moves over the nitrogen, neutralizing this positive charge. What is the name of this compound? It's something hydroxyl amine type compound. Then again another molecule of the hydrogen peroxide react as such in the same way as the first molecule of the hydrogen peroxide reacted. So you get positive charge, the positive charge on the nitrogen. What will happen? The deprotonation to stabilize this positive charge. So when this bond moves over here, after the abstraction of hydrogen ion, you get this compound. It's, what is the name of this compound? A gem diol. Two hydroxyl are directly attached to the same heteroatom. Then these species are highly unstable, containing two hydroxyl group attached to the nitrogen atom. So what happens when this bond moves here? This bond, the hydroxide leaves here, the hydrogen from here, hydrogen and hydroxide makes water, and you get RCH2N double bond O, nitrosoalkane. And we know that these nitrosoalkane readily tautomerize into oxime. How? Let's see. This is the same nitrosoalkane that is formed. So when this bond moves here, the bond moves here, oxygen gets negative charge and this hydrogen gets positive charge, and this hydrogen migrates from carbon to oxygen. This hydrogen has come from the carbon, so it's just the rearrangement of the hydrogen. So those isomers which are formed by just the migration of the hydrogen from less electronegative element to more electronegative element, such type of isomerism is known as tautomerism. So this is one of the class of the tautomerism, that is called nitroso-oxime tautomerism. So finally you get the oxime. These oximes are formed when primary amines react with hydrogen peroxide. So hydrogen peroxide oxidizes the primary amine into oxime. You will have to remember this. Now, oxidation of amines oxidation of no we have discussed the oxidation of primary amine. Now we will discuss the oxidation of secondary amine with hydrogen peroxide. Secondary amines react with hydrogen peroxide. The final product is just the derivative of the hydroxylamine. What is the name of this compound? It's a NN disubstituted hydroxylamine. NN disubstituted hydroxylamine. Now, what is the mechanism? The mechanism is very much similar as we have just learned. Amines are good nucleophile. They react here and this bond moves here. Hydroxide ion leaves and positive charge and the OH. These species are unstable because nitrogen is having positive charge. The hydroxide which left the system, it will abstract this hydrogen, so deprotonation will occur and nitrogen will be neutralized after abstraction of the hydrogen. So final product is the hydroxylamines. Now oxidation of tertiary amines with hydrogen peroxide. When tertiary amine, sorry, we have here, this is a tertiary amine. So when tertiary amine react with hydrogen peroxide, your final product is quaternary ammonium oxide. Quaternary ammonium oxide. How this transformation occurs? It's a simple tertiary amine. When it reacts with hydrogen peroxide, how it attacks on this oxygen, this bond moves over here, so hydroxide ion leaves and quaternary ammonium hydroxide, but the base abstract this hydrogen, so you get quaternary ammonium oxide as your final product. But this reaction is not so common. So what we have learned, that primary amines are going to react with the hydrogen amines and the final product is oximes. When secondary amine react with hydrogen peroxide, your final product is the hydroxylamine type derivatives. When tertiary amine react with hydrogen peroxide, your final products are quaternary ammonium oxide. And these quaternary ammonium oxides are not so stable. They get some stability with the removal of small molecules. Okay, so degradation occurs in these molecules. Your final products are maybe the degraded degraded alkenes. Now we will study the oxidation of aromatic and aliphatic amines with peracids. This is a very important reaction. So whenever primary amine or most commonly aromatic amines or the substituted aromatic amines, they react with peracid, and most common peracids that is used is the trifluoroacetic acid. So what happens, the amino group changes into nitro. So you get the nitroalkane in the first reaction, and aromatic nitro compounds in your second reaction. Now what is the mechanism for this transformation? You will have to remember that whenever aliphatic primary amines or aromatic amines, they react with trifluoroacetic acid, trifluoroperacetic acid, trifluoroperacetic acid. We have to add one more oxygen. Trifluoroperacetic acid. The amino group changes into nitro group. How this transformation occurs? This is an important mechanism. You'll have to memorize it. For the sake of the simplicity, I'm going to write this bigger molecule as pH. So you may assume that it is either the phenyl or the substituted aromatic compound, and it is attached to amino. What will happen in the first step? We know this is the peracid, trifluoroperacetic acid. This oxygen is electron deficient. How this single bond tends to move on this oxygen? What will happen when this lone pair attacks here? This bond moves here. So oxygen, trifluoroacetate ion, it leaves amino, making the new bond with this hydroxide through this nitrogen. What will happen? This trifluoroacetate ion, this is a conjugate base of this acid, it will abstract this hydrogen and this bond will move here. So you will get NH OH and CF3 C double bond OAH will be formed. What happens next? This react with another molecule of the trifluoroperacetic acid. How? Amines are more nucleophilic here, so lone pair attacks here, this bond moves here. So trifluoroacetate ion, it will leave, and nitrogen is going to make the new bond with this oxygen. So you are going to have this species. What will happen next? This trifluoroacetate ion, which just left in the first step it will abstract this hydrogen. So hydrogen abstraction will occur, this bond will move here, and you get gem-diol type species when this bond moves and this hydroxide leaves. So you, for in the first step you get the nitroso, sorry, this is pH, 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 pH. So nitroso, aryl nitroso type compounds are formed in the first step. Then what happens? It reacts with another molecule of trifluoroperoacetic acid. It attacks here and trifluoroacetate leaves. It makes a new bond with this hydroxyl group. Nitrogen will now have a positive charge because it's going to make a new bond with this hydroxyl group. Now we don't have any hydrogen attached with this nitrogen. So this base, the conjugate base of the acid, it will abstract this hydrogen. So you will get, what is this? This is the nitro group. So it means that the aromatic amines now have changed into aromatic nitro groups, nitro compounds. Let's take an example here. You have this compound and you will have to convert 1,4-diaminobenzene into 1,4-dinitrobenzene. So which reagent you will use? This is a question for you, whether you will use a hydrogen peroxide or trifluoroperoacetic acid. So you will have to decide which reagent is the best for this conversion. I have explained you the complete mechanism, that's how this transformation occurs. So if you have a two reactive sites in that single molecule, that what will be the product? For example, this compound is going to react with trifluoroperoacetic acid. This amino group will be converted into nitro group, and this olefinic double bond will change into epoxide. So your final product will be nitro compounds. So in last, we'll discuss the oxidation of amines using benzoquinone. Using benzoquinone. If you have an amine, when it react with benzoquinone or its derivative tertiary, this is a benzoquinone not solely is used However, its derivative is more effective for this conversion. Then final product is the aldehyde. Aldehyde. Now, how this transformation occurs, we'll discuss its mechanism. Then we'll study the specific example for this conversion. So what happens, I'm sure that in your previous classes you have learned that when amine react with a ketone, then oximes are formed. It react with this, so H2O leaves, and this condensation results into oxime formation. What is happening in this reaction? Just the condensation of a ketone and an amine. So what is happening? Just the condensation of a ketone with this primary amine results into an imine. Carbon double bond, nitrogen is formed. What happens next? When this bond moves here, this bond moves here, and then when this bond moves here and so the carbon will get a negative charge, it abstract this hydrogen, so you get this species. So in last, hydrolysis of these species forms this aldehyde. What will happen? I'm writing. What happens when water, it attacks here, this bond moves here, just the hydrolysis of this double bond. I'm not explaining because these steps are very much simple. Water attacks at this carbon, which is electron deficient. This bond moves over the nitrogen. Nitrogen will get negative charge, and this nitrogen will abstract this hydrogen. The bond moves over the oxygen to neutralize the oxygen atom. You get this species. Another molecule of the water, it attacks here. This bond moves here. You will get this species. What will happen next? This negatively charged amidine, it will abstract the hydrogen from this this protonated oxoniamine. It will abstract this hydrogen, and you will get a gem diol. And we know that gem diols are very much unstable. They get stability by eliminating water molecule from them. So finally you get the aldehyde. Today we have learned that three different oxidizing agents are used for the oxidations of amines, whether they are aliphatic or aromatic amine. Hydrogen peroxide converts primary amine into oxime. The it, hydrogen peroxide, when react with the secondary amine, it forms the hydroxylamine type derivatives. When it reacts with tertiary amine, then quaternary ammonium oxides are formed, which may be degraded to get some stability. To finally to they are formed hydroxylamine type derivatives. Then we discuss the use of the per acids for the conversion of the amino into nitro compounds. And in the last, when benzoquinone type oxidizing agents are used, they oxidize the amines into aldehyde. First they form the amines, and upon the hydrolysis of this amine, finally you get the aldehyde. Thank you so much.